Hi guys, welcome to lesson 8.8, our final lesson in chapter 8. And it is titled Factoring by Grouping. Our objective for this lesson is that I can factor higher degree polynomials by grouping. Some polynomials of a degree greater than 2 can be factored. And this grouping technique can also be used with polynomials that are not greater than 3 or greater than 2 for an exponent, and we can talk about how that happens later. So, question A, we've got 8x cubed plus 14x squared plus 20x plus 35. So the first thing you want to look for is just to make sure that there are no common factors that can be pulled out from all of your terms, and I don't see any here. So the next step would be to factor by grouping. So we put parentheses around our first two terms and our last two terms. And I always leave the plus sign in between the parentheses. Okay? So now, in this first group, 8x cubed and 14x squared, what common factors do we have? Well, they both have an x squared term in them, and they are both even, so they're both divisible by 2. So I can bring out a 2x squared. What's left in my parentheses is going to be a 4x plus 7. Okay. We have our plus sign. Now our second set of parentheses, 20x plus 35. What common factor can I pull out of that? Well, they're both divisible by 5, so I can bring out a 5. And I'm left with 4x and 7. So this is where factoring by grouping can be useful. So now I have this as one term and this is another term. Do I have anything that is common in both terms? And I do. It's this 4x plus 7 piece. This whole thing can be factored out. So if I bring that to the outside, I have 4x plus 7. What remains in my parentheses? Well, I have 2x squared, and I have a plus 5. And that is how we factor a cubic by grouping. Okay? So, just double check. Are there any common terms that we can factor here? No. Does this follow any of our rules for factoring? No. We're looking for a product of 10 that adds up to 0. That doesn't work. So this is completely factored. All right. Letter B, we've got 4x cubed plus 12x squared plus x plus 3. So again, I put my parentheses in place because there are no common factors here. My first set of parentheses, I can factor out 4x squared, and I'm left with x plus 3 when I pull out those common factors. Plus, what can I bring out of this? Well, I could just leave that as a 1 and x plus 3. So my common factor there is x plus 3. So we bring out x plus 3, and I'm left with 4x squared plus 1. Well, these are perfect squares, so does that rule? No, but this is addition. So remember, that was the difference of perfect squares. So this is completely factored. That is the best that we can do with that problem. You guys are going to try C and D on your own, and then I will go over the answers. So for letter C, we have x cubed minus 3x squared plus 6x minus 18. So we draw in our parentheses to break it up into our groups. And now we need to look for common factors. So what are my common factors in x cubed and negative 3x squared? Well, those common factors are just going to be x squared. So we bring that to the outside, and what are we left with? We have an x there and a 3 there. So we add 6x minus 18, common factor in that is going to be a 6. So we're left with x minus 3. We have a common factor in both of these terms of x minus 3. X minus 3, x squared plus 6. Okay. Letter D. First off, draw in your parentheses. And let's look at our factors. X cubed and 6x squared. Well, I can bring an x squared out of that. We have x plus 6. 7x and 42. I can factor out a 7 from that, and I'm left with x plus 6. X plus 6 and x plus 6 are my common factors again. So we have x plus 6 on the outside, x squared plus 7 on the inside. Okay? So essentially we're doing double factoring. We're factoring out one thing and then we're factoring again. Okay? Problem number 2. Factoring a polynomial completely. So this would imply that we have more than one thing that we need to factor. So let's just start with looking at it. Do I have any common factors that I can pull out of all of my terms? And, well, 6, 9, 12, 18. Those are all multiples of 3. So I can bring a 3 out from the whole thing. X to the 4th, x to the 3rd, x squared, and x. All of those have one x in them. So we can bring out an x as well. And let's see what we're left with. So 6x to the 4th divided by 3x. Well, that's just 2x to the 3rd. And we have minus 3x squared plus 4x minus 6. Okay? So now inside of those parentheses, we are going to draw in our grouping parentheses. So we've got the 3x out front, and I'm going to just kind of leave that way out in the front there. Can't forget about it. It still exists, but we're not doing anything with it right now. 2x cubed and 3x squared. Well, I can bring out an x squared from that, and I'm left with 2x minus 3 plus, we have 4x minus 6. What can I bring out of that? Well, I can bring out a 2, and I'm left with 2x minus 3. So now I've got these double parentheses, and actually I'm going to write that term out in front in black so you can see that it's not part of the factoring. It's on the outside already. It's not part of this factoring by grouping process. So I got 2x minus 3 and 2x minus 3. That's my common factor. So I keep the 3x out front. And now I bring out that factor. We have 2x minus 3. And then what am I left with? X squared plus 2. Okay. Now that gives me 3 terms. All of these are being multiplied. Okay. Letter B, same thing. We need to look and see, do we have any common terms that we can factor? And it looks like we do. We can bring out a 3 and an x from each of our terms. So we have 3x times the quantity, x cubed minus 4x squared plus 5x minus 20. Okay. So that 3x is going to stay out in front, and it's not going to be doing anything right now. Let's draw in our brackets inside here. So x cubed and negative 4x squared. Again, I can bring out an x squared from that. And I have x minus 4. 5x and negative 20. I can bring out a 5, and I'm left with x minus 4. So now we have 3x still out in front. It doesn't matter right now. X minus 4, x minus 4. What am I left with? X squared plus 5. Okay. All right, you guys try letters C and D on your own, and then we will go over them. So, in letter C, do I have any common factors I can pull out? Doesn't look like it. I've got no x's and everything. You know, my last term's just a 36. The first term doesn't have any coefficient at all, so I can't really factor anything out from that. So we're just going to start with our grouping. And when we have a negative sign like this, I always like to put a little plus in its place. So we're going to add that negative. We're going to add the opposite. Now, x cubed and 4x squared. My common factor in that is going to be x squared. And I'm going to be left with x plus 4. And here's that plus sign that I mentioned. All right, negative 9x and negative 36. My common factor there is a negative 9. And I'm left with x plus 4. Okay, so now we need to look at factoring that. So we have x plus 4 is our common factor. And I'm left with x squared minus 9. So we always want to double check, is there any other possible way we can factor it? And there is. X squared minus 9, that is the difference of perfect squares. So we have x plus 4, x plus 3, x minus 3. Okay. Letter D. We've got 2x to the or 25x to the third minus 25x squared minus x plus 1. So none of those are factorable. We are adding in between our parentheses there. So what can I bring out from my first term? I see 25x cubed, 25x squared. I can bring out a 25x squared. And I'm left with x minus 1. Plus, well, I got negative x and positive 1. I can bring out a negative 1, and I'm left with x minus 1. So my common factor of x minus 1. Then what's left? 25x squared minus 1. 25x squared, that certainly looks like a difference of perfect squares to me. So we have x minus 1, 5x plus 1, 5x minus 1. So you can see where recognizing those special cases is shortening our workload already. Okay. Let's move on to problem number 3, finding the dimensions of a rectangular prism. A rectangular prism has a volume of 60x cubed plus 34x squared plus 4x, and I want to know what expression can represent the dimensions of the prism using factoring. So we're going to start by factoring, and first look and see, is there any like terms that we can take out of either or any of these factors? And there is. We can bring out a 2x from everything. So we can bring out the 2x, and we're left with 30x squared plus 17x plus 2. All right, now let's look and see if we can factor that. Well, this is a way I can teach you how to do factoring by grouping with a just trinomial, a quadratic trinomial. So remember, we are a is greater than 1, so we need to multiply a times c. So 30 times 2 is 60, and our sum is going to be 17. So let's just start. We've got 3 and 20. That gives us a total of 23. Well, we could go 6 and 10, that gives us 60, but that gives us a sum of 16, so it's got to be a little in between these two numbers. Well, if I divide 60 by 5, I get 12, and 5 plus 12 is 17. So that's our winner right there. So we've got, we can do grouping in this way. We've got a 2x that's out in front, and we're not going to worry about that 2x. It's just out there right now. And then we write our first term, 30x squared. But now, when we did grouping, we had two pairs of 2. Well, I'm going to break this 17x up into two pairs. I'm going to break it up into two terms that are being added together, and my two terms are going to be 5x and 12x. So 30x squared plus 5x plus 12x plus 2. And we're going to close out our parentheses. Okay. So now we can go through and do our factoring by grouping because we have enough terms for it. So we put our parentheses in. That 2x is still hanging out in the front there. Now 30x squared and 5x, common factors there, well, they're both divisible by 5, and they both have an x in it. So we have a 5x. What I'm left with is 6x plus 1 plus 12x and 2. I can factor out a 2, so I'm left with 6x and 1. And now I can take out that common factor of the 6x and 1. So I get 2x times the quantity, 6x plus 1, times the quantity, 5x plus 2. And that is completely factored. Now, if you don't want to do the factoring by grouping route, you can do the factoring by a table or by a box method that I had taught you, and you're going to get to the same place. So I'll just do it real quick off to the side here. So we've got 30x squared, we've got a 2, and now we put in our two factors, 5x and 12x. Our common factor there is a 1. Common factor between 12 and 30 is a 6 and an x. 5 and 30, we've got a 5x, and 12 and 2, we've got a 2. So that would factor to 6x plus 1, 5x plus 2. Exactly what we got right there. Okay? So box method and factoring by grouping are both going to get you to the same place. It's just a little bit different work and a different way of thinking. Okay? All right, letter B, we've got a rectangular prism that has a volume of 4x cubed plus 12x squared plus 5x. What expression can represent the dimensions of this prism? Use factoring. All right, so first, look for common factors that we could pull out. Well, 4, we got a 4 there in that one, but there's a 5 here, so looks like all we can bring out of this term is an x. And I'm going to be left with 4x squared plus 12x plus 5. Okay, and I'm going to do this by grouping again. So I'm looking for 4 times 5 is 20. So I need factors of 20 that add up to 12. 1 and 20, that's 21. No. 2 and 10, that adds up to 12. So those are my factors. So we have that x hanging out in front. We have 4x squared. Now we're going to break that 12x into 2x and 10x. So plus 2x plus 10x. So basically we're kind of uncombining like terms. Okay. Now we break it up into our factors. Yay! We need to figure out what can we remove from here. Well, it looks like I can bring out a 2 and an x from both terms. So we have x out in front. So we have a 2x plus 1 plus 10x and 5. Looks like I can take a 5 out of that. And we're left with 2x plus 1. Okay. Common factors, we have a 2x plus 1 there, 2x plus 1 there. So we have x times 2x plus 1 times 2x plus 5. And that is our factored form there. Okay. You could also have used, once you got to this step, you could have used box method and figured it out from there and figured out these two terms from that. You're still going to get the same two factors, no matter which method you use to get there. Okay? All right. That's the end of the Chapter 8 notes. Make sure you fill out your level of understanding. Rate yourself 1 through 4 of how strong you feel about this lesson. Write down any questions or confusions that you may have, and write down a summary of how to factor higher order polynomials using grouping. Have a great night.